Wave optics numerical. Two slits in Young's double slit experiment are 0.4 into 10 raised to minus 3 meter apart. Interference fringes of width 1.5 into 10 raised to minus 3 meter are obtained on a screen placed 1.2 meter away from the slits. Calculate the wavelength of light used. If whole apparatus is immersed in water of refractive index 4/3, calculate the wavelength of light. Here small d is given, that is the separation between the slits is given 0.4 mm. And interference fringes of width 1.5 mm means we are given fringe width 1.5 into 10 raised to minus 3 meter. And here the screen is placed 1.2 meter away from the slits. The distance between screen and slits ಮತ್ತು ಸ್ಕ್ರೀನ್ ಮಧ್ಯೆ ಇರುವಂತಹ ಡಿಸ್ಟೆನ್ಸು ಕೊಟ್ಟಿದ್ದಾರೆ. ಅದು ಕ್ಯಾಪಿಟಲ್ ಡಿ 1.2 meter. What we need to calculate, ಏನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು? Wavelength lambda is equal to question mark. That is the first half of the question. It's very simple. Calculate the wavelength of light used. Lambda is equals to question mark. We have a formula, very simple formula, that is beta is equals to lambda into capital D divided by small d. Here beta is given, capital D given, small d given. You can calculate lambda. ಅದರ ಜೊತೆಯಲ್ಲಿ the whole apparatus, if the whole apparatus is immersed in water of refractive index is to 4/3, calculate the wavelength of light. Now this whole apparatus is immersed. ಈ whole apparatus ಏನದಲ್ಲ, that is immersed in a water, and the refractive index of water is 4/3. And now you need to calculate the wavelength of light. Okay, and there is a formula for that. The relation between refractive index and a wavelength of light. Okay, first let's find the wavelength of light used in first case. Calculate the wavelength of light used. Here what are the given things? Small d is given, beta given, capital D given, and wavelength of light in air you can easily calculate. Next, refractive index of water is given, and the wavelength of light in water ಎಷ್ಟಾಗುತ್ತೆ ಅದನ್ನು ಮಾಡಬೇಕು. First formula ಏನದ, beta is equal to lambda into capital D divided by small d. We want lambda, ಹಾಗಾಗಿ lambda is equals to, you can write the beta into small d, right? Capital D ಕೆಳಗಡೆ denominator ಬಂತು. Now substitute the values, substitute ಮಾಡ್ರಿ. Lambda in air is equals to beta, that is 1.5 into 10 raised to minus 3, small d 0.4 millimeter, capital D 1.2 meter. Okay, on simplification what you will get that ಏನು ಸಿಗುತ್ತೆ ನಿಮಗೆ, will get the wavelength of light in air is, that is 0.5 into 10 raised to minus 6 meter, or this is 5000 angstrom ಅಂತ ಹೇಳ್ಬೋದು ನಾನು, or 500 nanometer ಅಂತ ಹೇಳ್ಬೋದು. And you know the formula, that is, this formula is from your ray optics chapter. That is refractive index is equals to wavelength of light in air divided by wavelength of light in water. Okay, then use ಮಾಡ್ತಾ ಇದ್ವಿ. Wavelength of light in air ನಮಗೆ ಗೊತ್ತು, and we want wavelength of light in water, and here wavelength of light in water ಇದನ್ನ ಇಲ್ಲಿ ತಗೊಳ್ತೀನಿ, n ಇಲ್ಲಿ ತಗೊಳ್ತಾ ಇದ್ದೀವಿ. ಏನಾಯಿತು, here wavelength of light in water is equals to wavelength of light in air is 0.5 into 10 raised to minus 6 divided by 4/3, that is the refractive index of water. And rearrange, ಏನಾಯಿತು, denominator goes to numerator, 3 ಇಲ್ಲಿ multiply ಆಯಿತು, 0.5 into 3 divided by 4. Now it is 0.375 into 10 raised to minus 6 meter. What do you mean by that? Here the wavelength of light in water is, that is 0.375 into 10 raised to minus 6 meter ಅನ್ಬೋದು, ಅಥವಾ ನೀವು ಏನು ಹೇಳ್ಬೋದು 3750 angstrom ಅಂತ ಹೇಳ್ರಿ, or 375 nanometer.